standard response when an AI coding assistant is asked to build a login page. It immediately bypasses the planning phase, jumps straight into generating raw React code, and offers an explicit excuse: "I'll implement the edge cases later." Large language models are probabilistic engines designed to generate an output as quickly as possible. They optimize for the path of least resistance. This behavior is known as AI rationalization. The agent operates exactly like an overconfident junior developer who writes thousands of lines of code over the weekend and promises to write the tests later. Without strict intervention, those deferred tests and edge case plans are mathematically almost never fulfilled autonomously. The Addy Osmani/agent skills repository encodes Google's standard engineering processes into a programmatic workflow. The critical flaw in AI code generation is not a lack of reasoning capability within the underlying model. The flaw is the absence of an enforced programmatic engineering process surrounding it. For tech leads and senior engineers, reviewing AI-generated pull requests introduces a massive hidden overhead. Typical AI outputs consistently omit product requirements documents. They ignore established security boundaries and confidently hallucinate framework usage without checking the documentation. Because the AI operates with a localized view of the immediate file, it generates quick fixes that silently break global architectural patterns. If a developer spends 50% of their time reviewing, debugging, and refactoring architectural flaws in AI output, the coding assistant is a net negative to the team's velocity. This raises a question: what happens to team productivity when you hard code an interceptor that physically blocks the AI from writing a single line of code until its logic is rigorously proven? The agent skills repository discards monolithic system prompts, replacing them with a rigid lifecycle based on Google's engineering culture. This lifecycle operates through 7 specific / commands, moving sequentially from /spec and /plan all the way through /build and /test. This anti-rationalization table maps an LLM excuse directly to a counterargument, terminating at a rigid verification gate. The tables anticipate evasions. If the agent claims verification is too complex, the gate forces it to execute assertions instead of skipping. Verification is non-negotiable. This system relies on an architectural concept called progressive disclosure. When you load a 10,000 token master prompt detailing every coding rule into an LLM, its reasoning degrades. It suffers from instruction drift, forgetting earlier constraints as it generates more text. Progressive disclosure solves this by feeding the agent isolated workflow steps, loading the /test skill only when testing begins. This keeps the token context focused entirely on the immediate task. This architecture of isolated workflow triggers allows for precise control over agent capabilities at every stage of the build. Let's trace a concrete implementation where Claude Code builds an API endpoint from scratch. During the initialization sequence, the /spec command forces the agent to pause. It must output a comprehensive Markdown product requirements document outlining objectives, structure, and boundaries before drafting any code. Next, the /plan command initiates task decomposition. The agent breaks that overarching spec down into small atomic units with clear dependency ordering. Execution begins with the /build command, forcing a test-driven development loop. The code is constructed incrementally in thin vertical slices. This chart displays the exact test pyramid enforced during the /test verification phase. The agent is required to deliver coverage structured precisely as 80. The programmatic rule is absolute. The agent is mathematically forbidden from deleting or modifying legacy code unless it first generates proof that it understands exactly why that original code exists. For testing standards, the framework introduces the Beyonce rule. The mandate states, if you liked it, then you should have put a test on it. This translates into mandatory test coverage for all critical logic paths, no exceptions. Finally, there is the source-driven development protocol. This protocol effectively eliminates LLM hallucination by forcing the agent to cite official documentation for every architectural and framework decision it makes. By enforcing these constraints, the repository bridges the gap between simple text generation and secure production-grade integration. The agent skills package acts as a centralized module, upgrading standard IDEs so they operate with the discipline of autonomous engineers. There are specific integration pathways for tools like Claude Code, Gemini CLI, Cursor, and Windsurf. In Cursor, for instance, you copy the skill files directly into the .cursor/rules directory, or utilize external MCP servers. There are immediate friction points to navigate. Older IDEs often struggle with dynamic skill imports, requiring developers to manually copy and paste the workflows to get them functioning. Before you deploy this workflow into your production environment, you have to understand a critical architectural trade-off. Enforcing staff engineer standards through these workflows will drastically slow down the raw speed of your weekend prototyping. This chart maps the trade-off. The system demands human rigorousness. If the developer fails to define clear, coherent specs up front, the resulting process will feel bloated, slow, and overly complex. It forces us to ask, are raw AI prompts actually making us worse engineers by encouraging us to skip the planning phase entirely? If you found this breakdown valuable, subscribe to the channel for weekly deep dives into technical tools and system architectures. Speaking of rigorous engineering principles, in our next video, we dissect the inner workings of Google anti-gravity. We will see you there.